Alkanone. Alkanone. We are still dealing with functional groups of organic compound. Alkanone. The functional group present in alkanone is simply CO or CO. That is the functional group present in alkanone. If you watch from alkanoate that we did, it looks similar. But remember, alkanoate has double O, it has double oxygen. But here, it has only one oxygen. It has only one oxygen. One oxygen is present in alkanone, while in ester or alkanoate, you have two oxygen atoms. These are two molecules. If you watch, this thing can be written like this. If what you call the structure of alkanone, it can be like this. That's the structure of alkanone. Now, in naming alkanone, you don't have any problem there. You are just naming straight. You are naming according to the number of atoms, carbon atoms it has. According to the number of carbon atoms it has. Don't forget, subsequent videos will be on how you pack nomenclature for organic compound. How we use how you pack nomenclature to name organic compounds. So all these ones are just coming so that you can know their functional groups. So that when we now dive into how you pack nomenclature, anyone you see this functional group, you already know where it belongs to. That is the reason why I decided to make the video of functional groups first, so that you can be able to identify, because I have told you, functional groups helps to identify where an element belongs to. For instance, when we did alkene, so anywhere we see a double bond or even alternate double bond in a compound, we know that that compound belongs to alkene. So for this one, if you see CO anywhere, you know that it belongs to alkanone. You know that alkanone has another name. It can be called ketone. That's another name, ketone. So let me just give one example. You can learn this one. Let me expand it. The same thing, this is the condensed structural formula, while this is now the structural formula. So this is, how many carbon does this thing have? 1, 2, 3, 4. 1, 2, 3, 4. So the name is butanone. Remember, 4 carbon atom is what? Butanone. Don't forget, we are not dealing with IUPAC yet. This is just to expose you to the functional groups, so that when we now start the IUPAC nomenclature, you get the whole thing clearly. So another example now, let me just give another one. All these ones, hydrogen, hydrogen, and hydrogen, 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 hydrogen. So you can now add your hydrogens here. So count how many carbon that is there. 1, 2, 3, 4, 5, 6, 7, 8. So the name is what? Octanone. Because it has 8 carbon atoms. Octanone. 8 carbon atoms. The next functional group you are checking, or homologous series you are checking, is aldehydes or alkanone. Don't forget the salt is Al. So the functional group present in aldehyde is simply CHO. You can expand it as you like. CHO. This is the alkanone functional group. This is what makes exultans an alkanone. Alkanone. So, or aldehyde. So an example of it is C3CHO, which is simply ethanol. Remember, the functional group is here. The carbon present in the functional group is added to the number of the compound. So 1, 2, ethanol. Okay, you can see CH3, CH2, CH2, now CHO. So you can name this one. How many carbon atoms does it have? 1, 2, 3, 4. This one is a butanol. It's butanol. Just know that alkanol has the functional group of CHO. CHO. The next functional group is amides. The amides has the functional group of CONH2. You can expand it as you like. And of course, this is a R. So that is amide. Amide. So, and the name is simply about the number of carbon atoms it has. You just remove E ending of alkane and put amide. For instance, C2H5CONH2. So how many carbon atoms does this thing have? 3, I guess. 2 plus 1 is 3. So this is simply propanamide. So remember, from normal propane, the E ending of propane has been removed and substituted with the parent name amide. Propanamide. Remember, propanamide. Look at the surface. So the whole parent, the full name of the parent is what is used at the surface. Propanamide. So it is named according to the number of carbon atoms it has that has been established. Example 2, CH3CO NaH2. How many carbon atoms does it have? Or does it has just ethanamide? Because it has only 2 carbon atoms, 1 and what? 2. So the first anywhere you see from the formula of a compound, you see CONH2. Take your mind to amide. Take your mind to amide. That is where it belongs to. Let's check the next functional group, which is amines. This one is a amides. It's not the other one is amide. This one is amides. In amides, there is no CO. So the functional group present here is just NH2. Any compound you see, share the same formula like a protein, amino acid, just like an amino acid. So you just NH2. Any compound you see like that has this thing, you take it to amines. It is just named according to the number of carbon atoms it has. Let us check the simplest one. How many carbon atoms is here? It's 1. So the name of this thing now will be methylamine. The name is even sweet. Methylamine or methylamine. You just, because this is a methyl group, you just put the surface of the name, the full name of the parent is used as the surface. Methylamine or methylamine, as the case may be. C4H9 and NaH2. This one is a butylamine. Butylamine, because it has 4 carbon atoms. Butylamine. Okay, that is it.